Hey, what's up everyone? Welcome to Descriptive / Laboratory Chemistry Part 3. Today we're going to be talking about acid-base neutralization reactions. So an acid-base neutralization reaction is going to have a general form of an acid and a base reacting to produce a salt and water. And an acid-base neutralization reaction kind of defines what a salt is. A salt is an ionic compound that results from an acid-base neutralization reaction. And to see an example of this, let's look at what happens when hydrochloric acid and sodium hydroxide combine together. A lot of acid-base neutralization reactions are going to be a double displacement reaction, and this is going to be one of them. So the hydrogen is going to pair up with the hydroxide to form H2O, and the sodium is going to pair up with the chloride to form NaCl, which is sodium chloride. Now, in this case, the salt that we produced was NaCl, which is table salt. So this is one of the ways that you can produce table salt. But generally, this is it. This is all an acid-base neutralization reaction is. It's an acid, in this case, it's the hydrochloric acid, and a base, in this case, it's the sodium hydroxide, combining to form water, and a salt, in this case, the sodium chloride. Although this is the chemical equation here, this isn't what the reactants and the products look like in the solution. So remember, all this is going to happen in some container of water here. And when you put the hydrochloric acid in the water, it's going to immediately dissociate into H+ ions and chloride ions. So we have H+ ions and chloride ions instead of the hydrochloric acid molecule. And the same goes for the sodium hydroxide. So instead of NaOH, the NaOH is going to immediately dissociate into Na+ ions and OH- ions. And that is going to react to form water and sodium chloride. The water that's formed here is going to be in the liquid form. So that's not going to be able to dissociate, but the salt that we have here, the sodium chloride, is going to be aqueous. The fact that it's aqueous means that it's going to be dissolved within the water. And what that means is that it's not going to be in its normal molecular form. It's not going to be in sodium chloride form, but it's going to be split up into its ions. So we're going to have H2O liquid, and we're going to have sodium ions and chloride ions. So this is what the reaction really looks like if you look at the reactants and the products. And what we've done here is that we've written the complete ionic equation. There's one last thing to notice about this complete ionic equation here, and it's the fact that certain ions are present both on the reactant side and on the product side. In this case, we have both the sodium and the chloride appearing on the reactant side and the product side. So what we can do is we can cancel out the sodiums and we can cancel out the chlorides. And that leaves us with H+ reacting with OH- to form H2O liquid. And this is what we call the net ionic equation. Net ionic equation. So here's a little summary of all that information. We have the normal equation here where hydrochloric acid and sodium hydroxide are combining to form sodium chloride and H2O. In the complete ionic equation, we have H+ ions, Cl- ions with sodium ions and hydroxide ions combining to form sodium ions, chloride ions, H+ ions, and OH- ions. And the net ionic equation is that H+ ions and OH- ions are combining to form H2O. Let's do one more example of this kind of thing, and let's look at this reaction here. First of all, let's try to write the complete ionic equation here. So we have 3 NaOH. The NaOH is going to dissociate into Na+ ions and OH- ions. So we're going to have 3 Na+ ions, and we're going to have 3 OH- ions. Now let's look at the phosphorus acid. Phosphorus acid is a weak acid, which means it's not going to dissociate very much. And for that reason, we can keep it in H3PO3 form. And now we can start talking about the products. First of all, we have the water. And the water is in its liquid form, which means that it's not going to dissociate. It's just going to stay in H2O form. And the last one, we have a salt, Na3PO3. And since it's a salt, it's going to dissociate completely. So we're going to have 3, that should be a plus, sorry. We have 3 Na+ ions, and we have 1 PO3 3 minus ion. And what we have here is called the complete ionic equation. And to turn the complete ionic equation into the net ionic equation, you have to cancel out the ions that are found both on the reactant side and the product side. Those are what we call the spectator ions. And in this case, the spectator ions that we have are going to be the sodium ions. So as soon as you cancel out the sodium ions and rewrite your equation here, it's going to be 3OH minus reacting with H3PO3 to form 3 water, H2O, and a phosphite ion. And that is your net ionic equation. Net ionic equation. And that's acid-base neutralization reactions, and how you find complete ionic equations and net ionic equations of an acid-base neutralization reaction. That's all I have. I hope you were able to learn something, and I hope to see you later. Thank you.